Next we will let you know how to find the what is meant by steepest descent briefly. Here first take an initial graph. This is the consider it as one graph, and here let take assume initial point as 2 comma 3, 2 comma 3. Here is the that point, and here next point we have to find means it is the initial guess, so it is not confirmed that this is the only minimum point. So we have many other minimum points, so we have to find that minimum point. Means we have to move to the next iteration point, and again we will check that it is a minimum or it is a maximum of the function this point, initial point. So in order to find that we will take an gradient. It is nothing but it is known as first from this point in which direction it has that points, means in which direction we have to move to get minimum point. So this gradient function will tell us in which direction we have to travel. There are many ways to travel. This gradient will show, for example, in this direction we have to move, so this gradient will find the this is the direction we have to move. In next point after getting path, after we have to move this path, so next is we have to find, next one is we have to know how much distance we have to travel. Step size, step size means alpha value. Alpha value will tell us how much distance we have to travel. Means we have like direction, gradient means it will show direction, but we have to know how much distance we have to travel in the what distance in that direction. So next in this alpha value means step size will show we have to miss some distance, this much distance. Here we will get the another point. So this is the another point called as 4 comma 4. This is the new our new steepest descent iteration value. So we will assume that this is the value, this is the minimum value, and we will compare with the past value. So it is not the minimum value, so again we have to move in we have to find the gradient term, and we have to find the alpha term. Next we will there are many ways from here, so we again we will move another point. So assume this as 1 2 comma 2 comma 2. So this is also not we will find again, and we will compare with the previous terms, and we will compare with the 0, and if it shows that this value is not minimum means we will again find out the another value. This is called as 1 comma 2. So this is the assume that this is the minimum value, so we got the answer. So like this we have from every point we will have the some directions. So in each iteration we will find out the gradient and step size. So this is the total formula. This is the algorithm of what we have to follow the steps. First we should have the gradient function, objective function, and we have which is to be optimized and define. First we have to define the gradient function of the objective function, and first we have to choose initial case of the minimum function, and next is step size of each iteration of the algorithm, and set a stopping iteration. Means if we don't have a stopping iteration means we have to do continuously finding the minimum value. So if we have, for example, take an stopping iteration 10, after reaching 10 it will stop the iteration one. Means in the So there are till iteration 10 there are some set of iteration values like 10 iterations values. We will compare in each iteration means in which value we will get least, so that will be the steepest descent iteration value. So this is the test algorithm benchmark. And next we will go to the iteration. This is the main formula of the gradient steepest descent method. This is the x of k plus 1 is the next iteration. How to and these are the values are used to find the next iteration value. And here x of k is the minimum iteration value, and x of k plus 1 is the iteration max means next updated I guess iteration value. Alpha k is the steepest size, and alpha del f of x comma f of x is the gradient of the function. And these are the example problem. First we will take a grade objective function. We will substitute some initial values x comma y as the minus 3 comma 2, and we will substitute these initial case values in the gradient means update. We will find out the differentiate. We will differentiate this f of x comma y, and we will substitute this initial case into these values, and we will find out the some gradient of the function as to minus 2 comma 14. And these are the total steps we have to follow, and we will find the alpha value which is means by step size, and we will find out the next iteration x1 and y1. So after doing this process again and again, we will find we will get the x comma y 1 comma 1 the, and this 1 comma 1 point is the minimum of the function. And this is the my python code. We will write a python code in the um, we will write the steepest descent method in the python code. And first initially we will give the x1 x and f of x means for objective function, and a number of iterations we will give, and this is the alpha one means how much distance we have to travel, and this is the gradient of we will compare we will give the gradient term function to the gradient of f of x, and x is equal to alpha into gradient of x, and after reaching the f of x it will number of iterations will be updated. So like this, and this is the f of x means a objective function, and we have to find the values of the steepest descent method. Next, area of application. In this steepest descent method it will be used in various applications, and in that linear regression, logistic regression, neural networks. In logic overall these are used to find the decrease the cost function. In machine learning, cost function will play a crucial role, because um, we we will compare the actual predicted values and actual values and predicted values, because we have to decrease the error function. That is called as cost function. The example take an probability problem statement. Suppose we have a set of house prices in a certain area. The data set consists of two variables: the size of house and the price of the house. We want to build a linear regression model to predict the price of a function house based on its size. So we will use the steps descent method to find out the cost of the house. We will perform a as we will choose assume m is equal to 0 and b is equal to 0 as the initial values, and we will these are the here dms by dm is the gradient of the function, and these are the steps we will have to find a learning rate. Learning rate is nothing but parameter that controls the size of steps taken in the direction of the negative gradient. And next we will go to the, this is the code for the implementing above problem statement. First we will give the initial values, and next we will set a step size, and we will compute initial guess, and this is the computing gradients. This is the gradient. This is the gradient, and we will update the parameters after getting gradient values, and this is the function to finding the next iteration we will find here, and this is the last. After doing this we will get the minimum of a function. This is the references what we in what we I have searched for. Thank you.